In this video, we will solve a tricky question on demand function and how to calculate the elasticity. The question is demand function is given by quantity demanded is a function of price, which is equal to 10 minus under root P. P denotes the price. Find the interval of prices for which the demand is positive. Second question is express total revenue, that is total revenue is equal to price into output as a function of prices. When is the total revenue maximized? We need to find out that very quantity for which price elasticity is equal to -1. Okay, so let us solve it one by one. So we have the demand function, that is Q is a function of price, which is 10 minus, in place of under root P we can write P raised power 1 upon 2. This is our demand function. Okay, so first thing is we have to find out the interval of prices for which demand is positive. Okay, so for quantity to be greater or equal to 0, that means let us plug Q is equal to 0 in this equation to find out the interval of prices where demand is positive. So for demand to be positive, let us substitute here. So we have 10 minus P raised power 1 upon 2 is equal to 0, which implies P raised power 1 upon 2 is equal to 10 here. Transpose this, it becomes square. So we have P is equal to 10 square, which is equal to 100. Okay, so as long as, so it implies prices should be less or equal to 100 for quantity to be positive. Okay, so as long as prices are less or equal to 100, quantity demanded will be positive. Second question is we need to write the total revenue as a function of prices. So we know that total revenue is equal to price into output. So since we have to write it as a function of price, okay, so we have the demand function, this function. Okay, so we can write as we have P into the value of Q is 10 minus P raised power 1 upon 2, which will be equal to 10P minus P raised power 1 upon 2. Okay, so we have P in place of Q, we have this function. So this is our total revenue, that is quantity as a function of prices is equal to 10 P minus P raised power 1 upon 2. Let me see if I have done it correctly. No, here it will become 1 plus 1 upon 2. 1 plus 1 upon 2 is 3 upon 2. So here we have 3 upon 2. 3 upon 2. This is our total revenue as a function of price that the question was asking us. Then we are told when is the total revenue maximized. Okay, so to find out the total revenue, that is the maximum of the total revenue, we need to find out the marginal revenue. But marginal revenue is a function of output, so we need to find out the total revenue as a function of output. So total revenue will price into output, which will be equal to, so we solve this given demand function as inverse demand function first. Okay, so since we have Q is equal to 10 minus P raised power 1 upon 2, solve it for price here. So we have P raised power 1 upon 2 is equal to, P raised power 1 upon 2 is equal to 10 minus Q. Transpose this this exponent, it becomes square. So P will be equal to 10 minus Q raised power 2. So 10 minus, so we can rewrite it like this using the identity A plus A minus B whole square is equal to A square, which means 100 plus B square minus Q square minus 2 into 10 into Q is 20Q. So this is our inverse demand function. So in place of P we write Q square minus 20Q plus 100 times we multiply it by Q. So our total revenue will be equal to Q cube minus 20Q plus, rather here square, plus 100Q. Okay, this is our total revenue. Now for this total revenue to be maximized, for total revenue to be maximum, marginal revenue should be equal to 0, and marginal revenue is simply the change in the total revenue due to the change in the quantity, that is Q. So differentiate it with respect to Q. Derivative of Q cube is 3Q square minus derivative of Q square is 2Q, so 2 into 20 is 40Q, and derivative of Q is 1, so we are left with 100, and we set it equal to 0. Now let us solve this. So for total revenue to be maximum, marginal revenue should be equal to 0. Marginal revenue is simply the derivative of total revenue function with respect to output, and we set it equal to 0. Since this is a quadratic equation, let us solve it using the quadratic formula. So we have the coefficient of Q square is 3, let us say it is A, coefficient of Q is negative 40, let us say it is B, and we have constant term C. So we know how to solve. So Q will be equal to minus B plus minus B square minus 4 times A times C upon twice A. Okay, so here we will get, so we have minus B, negative B here from the formula. So negative, then the value of B is negative 40, then we have plus minus negative 40 square, then we have minus times 4, from the formula A is 3, C is 100, divided by 2 times A, 2 times the value of A is 3. So solve it further. So negative into negative is positive, we get 40 plus minus square of a negative number is positive, so it becomes 1600, minus 4 6 are 12, into 100 is 1200, upon 2 into 3 is 6, so we will get 40 plus minus 1600 minus 1200, it is 400 upon 6, or we will get 40 plus minus, so root of 400 is, we can write it like 20 square is 400, square root gets cancelled, we are left with 40 plus minus 20 upon 6, which is equal to 40. Okay, so here either when we solve this, we got Q is equal to either 40 plus 20 upon 6, or Q is equal to 40 minus 20 upon 6. So we got two values for Q here. So let me rub this out, which implies Q will be equal to 40 plus 20 is 60 upon 6 is 10, or Q will be equal to 40 minus 20 is 20 upon 6, so we get 20 upon 6 is 6, 3s are 18 point, then again 6 point, so we get something Q is equal to 3.33. So we got two values for Q. Okay, since we had to find out the maximum of the total revenue, so first condition was marginal revenue should be equal to 0 for maximum. So if I have this kind of function, okay, so first thing is marginal revenue should be equal to 0. Second condition is that the slope of the marginal revenue function should be negative. Okay, so first order condition for maximum was marginal revenue should be equal to 0. For that we got two values, Q is equal to 10 and Q is equal to 3.33. Second order condition for maximum is that the slope of marginal revenue, that is slope of marginal revenue function, should be less than 0. Okay, at the critical point. So where did we solve for marginal revenue? So this is our marginal revenue function. Okay, so this is the marginal revenue function. Now its slope is the derivative of marginal revenue function, again with respect to output. Okay, so slope of marginal revenue means the derivative of marginal revenue function with respect to output, and we need to find out it is sign here. So again differentiate this. So 2 into 3 is 6Q, 6 is Q minus 40, and we need to evaluate it at the critical points. Okay, so we need to find out the slope. So this denotes the slope of marginal revenue function. and we evaluate it at the critical points that we find out here. Okay, so when q is equal to 10 in this equation, that means uh, the slope of mr when q is equal to 10, let us find out. So let us plug 6 here, 10 here, so we have 6 times 10 minus 40. So it is 6, 10 times 10 is 60 minus 40, it is negative 20. So negative 20 is obviously less than 0. That means total revenue will be maximized when output level is 10. And we can check it for another condition, another critical value. So when q is equal to 3 point, let us say 3, what will be slope of marginal revenue function when q is equal to 3.3. Sorry for this notation, I have not space here to write it properly. So plug here, so we have 6 into 3, sorry, I have done a mistake here. 6 tens are 60 minus 40 is full of positive 20. Okay, so it is positive 20, so this will not maximize the slope, this will not maximize the total revenue. So when q is equal to 3.3, so we have 6.6 into 3.3 minus 40, so it will be something 18 point something. So let us say it is 18 point something, 18.5 minus 40. Obviously this number will be less than, which is less than 0. Okay, so let me repeat it here. When q output is equal to 10, we got the slope as positive, but for maximum slope should be negative. So slope of marginal revenue when q is equal to 10 is equal to 20, which is greater than 0, which does not satisfy the second order condition for maximum. When output is 3.3, slope of marginal revenue came out to be so let us find out here specifically. So we have 40, we have 18.5, so 5 and 10 5 point को point 9 so 21.5. So here we got negative 21.5, which is less than 0. That means when so q is equal to 3.3 satisfies second order condition for maximum. Okay, how did it satisfy? So output here we have total revenue and marginal revenue on the horizontal axis, and let us say total revenue also. So we have this total revenue function here. Okay, so we got two values, and I don't know how to draw it here. So when q is equal to 3.3, so it will look like this. I guess it should look like this. Okay, so let us say this is our total revenue function. So slope is equal to 0 at this point, but since we have to find out the maximum, so when x is equal, when q is equal to 10, slope is equal to 0. When q is equal to 3.3, slope is equal to 0. But to find out the maximum value, the slope of the marginal revenue function should be less than 0. That means at this point slope should be negative, and we have found out here the slope of marginal revenue function with respect to output should be less than 0. So it occurs when q is equal to 3.3. But here we got output is 10, but we got a minimum point for the total revenue when output is equal to 10. So total revenue will be maximized when output level is 3.3. Okay, so coming to the next question, and let me see if I am within my 859. Okay, so I have now what should I rub this time to solve for the elasticity question. Okay, so I hope you got this point, and I will repeat it again. Now for elasticity, okay, so for elasticity to equal to -1, so we know elasticity is the change in the output due to the change in the price into price upon output should be equal to -1. So dq upon dp we are supposed to find out. Okay, so dq upon dp, so we have q is equal to 10 minus p raised power 1 upon 2. This is our demand function. So So its derivative, that is dq upon dp, will be, so solve it, takes derivative of constant is 0, derivative of this will be negative 1 upon 2, because we have negative here, p raised power, exponent is subtracted, so we get 1, negative 1 upon 2. So dq upon dp is negative 1 upon, and this can be rewritten as negative 1 upon twice transpose it here, if slope, the exponent becomes positive, so we get this thing here. Okay, so we got minus twice p raised power 1 upon 2 times we have p divided by q is this 10 minus p raised power 1 upon 2, and it should be equal to negative 1. Okay, so solve further, so we get negative times, so this negative sign gets cancelled on both sides, so let's multiply this to this, so we get 2 into 10 is 20, p raised power 1 upon 2, then we have again twice p raised power, so p raised power 1 upon 2, p raised power 1 upon 2 becomes p, because exponent sign get added to 1, should be equal to 1, so we have twice p raised 20 p raised power 1 upon 2 minus 2p should be equal to p, or 20 p raised power 1 upon 2 is equal to, transpose it here, it becomes 3p, or 3p is equal to 20 p raised power 1 upon 2, or okay, have I done it correctly here or not? No, okay, so we get here 3 upon 20, or transpose this here and this there, so we get p divided by p raised power 1 upon 2 is equal to 20 upon 3, so it becomes p raised power 1 upon 2 when we solve it, because if I transpose it here, it gets multiplied and exponent sign changes, so we get 20 upon 3, or p will be equal to 20 upon 3 square, or price will be equal to 20 into 20 is 400 upon 3 3s are 9. So this will be the price where elasticity is equal to 1. I hope I make myself clear, and if there are any mistakes, please let me know. I have done it in haste manner here. Hope you like this video. Thank you.